Good afternoon, class. Today what I'd like to do is to start a series of videos on how to deal with force problems. So this will be a 5-part series. This is the first part, which deals with Newton's second law, F equals ma. The second part will be using the gravitational force problems, F equals g m1 m2 over r squared. The third part will be on momentum problems, or forces in momentum collisions, which is F equals delta p over delta t. Part 4 will be on electric force problems, so using the equation F equals K Q1 Q2 over R squared. And the last one, part 5, is going to be using magnetic forces, which would be using the equation F equals QVB. These can all be found in later parts of the series, so don't worry about those, whether or not you remember those equations for now. For today, for this video, what I'd like to do is focus on Newton's second law, F equals ma, and instead of finding one of the problems to work on from the homework, what I thought was, why don't we answer a question that generally puzzles us about, that has application in our everyday life, which is, what is our weight here on Earth? And so for this problem, I used myself as the example, so I'm going to use my weight, or I'm going to find out my weight here on Earth using my mass. Now, in this example, I put down my mass as 100 kilograms. This is not my actual mass, but my mass is close enough to 100 kilograms where it's a good approximation and it makes for a fairly easy calculation. So that is why I use it. Feel free to do the same technique, especially when we do other labs where you're going to need to actually write down your mass. So that's where the 100 comes from. The acceleration is due to gravity, so that's why I said A equals G, because that is the traditional method of writing down what the acceleration is, or to distinguish any acceleration in the horizontal direction with gravitational acceleration in the vertical direction. So that's why acceleration is equal to g, and g is equal to 9.8 meters per second squared. This is an average. Even though it's a constant across the Earth, it's really an average number. It's not very precise, and it depends on where you are on the Earth, because the Earth, first of all, is not a perfect sphere, so it doesn't have an exact radius towards the center that's consistent all across the surface of the Earth. And of course, the rocks and the Earth that is below you could be a little bit denser or less dense depending on the conditions of the planet and where you are on the planet. So this 9.8 is a very average number. So what you'll see in part 2 of this series is that this number gets challenged a little bit. So what I write down here, just as a forewarning, that this number here, even though I get an exact number, it's not really a good exact, it's not in real life an exact number. It's really only an approximation. So, and you'll see that more when we go do part 2 of this series. But anyway, for now, let us start with F equals ma and find out what my weight is here on Earth. So that's where I got all my numbers. Let's plug them into the equation. My mass is 100 kilograms, and the acceleration is due to gravity, which is 9.8 meters per second squared. If you'll notice, what I'm employing in this video is to use the shortcut method, so that it becomes so that we can focus more on the math side and not so much trying to work out all of the units, which we can work on in future videos. So 100 times 9.8 is 980, and therefore my weight, or the force of gravity here on Earth for me, is 980 newtons. So that concludes how to deal with forces using Newton's second law. Good luck in your studies, and may the force be with you.